Why, hello there. Mr. Lee here. All right, numbers 38 to 41 is the last bit of your review sheet. Um, so, finding sums, we are in summation notation or sigma notation. So, number 38, we have this formula, -1 to the power of n plus 1 times n squared. Okay, so this one is neither arithmetic or geometric, so we're not going to use a formula. But your starting index is 3, ending is 6, so there's only a few numbers to actually calculate, right? So I'm going to use the power of the calculator to help us out, but really I'm just plugging in numbers, right? Your first index is 3, so if I plug in 3 into this formula, it'll equal 9. And then it goes from 3 to 4 to 5 to 6. Okay, so these are all your values when you plug in the n values of 3 to 6. And if we're just doing a summation, it just means we're adding up all these numbers, right? So there's only 4 numbers in this sum because we're starting at 3, ending at 6. So it's simple as saying 9 minus 16 plus 25 minus 36. Your sum should be a total of -18. Okay, and then we're going to use the graphing calculator to even check it for us, right? So again, this is just a check. You're not going to be able to use this on like the test or anything, but if we just type in the whole sum, it proves that the sum is -18. All right, so that was 38. Number 39. Number 39, we have the formula is 2 minus 4n. Starting index is 3, and it goes all the way to 85. Okay, so I'm going to start by finding the endpoints, basically. So your first term has an n value of 3. Okay, so there's an offset of what n value you start at. You're not starting at n equals 1. You're starting at n equals 3. So this is basically your first term, -10. That's when you plug in n is 3. And your last term should be when n is 85. That would be -338. Now, there is a formula. This is, you do have to recognize this is an arithmetic series. All right, so the 2 minus 4n, this is linear in nature, so it means it's arithmetic. Your common difference is -4. So the formula for the sum of arithmetic series is this. Hopefully this looks familiar. So it's a total number of terms divided by 2, multiplied by the first and last term added up. All right, so we already have A1. That's going to be -10. And then you already have the last term, which is -338. Right, that's plugging in the starting and ending index. Now, the total number of terms, which is n, that's a little bit trickier because we have this offset, right? We're not starting at n equals 1, we start at n equals 3. If you started at n equals 1, then there would be a total of 85 terms, right? But because we're starting at n equals 3, there's basically 2 less than that. There should be 83 terms. So it's going to be 83 over 2. 83 is the total number of terms, multiplied by a sub 1 plus a sub n. So the total sum should be this number right here, -14,442. Let's just double check to make sure we're not crazy. So 3 to 85, then we have 2 minus 4n. There we go. It matches. All right, that is number 39. On to number 40. Number 40, our formula is 48 times 4/5 to the power of n. This looks like an exponential, right? We have an r value, common ratio, so this is geometric. We have a total of 26 terms, right? Because your starting index is 0, ends at 25. So we definitely want to use a formula for this. We don't want to sit here and, figure out n is 0, 1, 2, 3, 4, all the way to 25, and then add them up. It takes way too long. So the sum of a geometric series is going to be, and I think this formula is on your review sheet already, but it's a sub 1 times 1 minus r to the n power over 1 minus r. A sub 1 is when you plug in your starting index. So again, be careful. Your starting index is 0. So it's not as simple as just plugging in 1, right? Starting index is 0. So this is actually a sub 1, which is 48. Your r value is the 4/5, right? That should be, you should be able to identify that in the formula. And then n is a total number of terms. This should actually be 26, like we talked about, okay? From 0 to 25, you actually have 26 total terms, not 25. Okay, so let's plug that all in. A sub 1 is 48, multiplied by 1 minus a r value of 4/5 to the power of your total number of terms, 26, all over 1 minus 4/5. So 239.275 if we round it to 3 decimal places. 275. And again, we'll double check everything. So from 0 to 25, with this formula, should be the 239.275. Beautiful. All right, last one. Last one is an infinite series. Our formula is 24 times negative 2/3 to the power of n. It's another geometric, right? Some initial value times the r value to the power of n. This is infinite, okay? So we definitely have to use a formula. It's going to be the same formula, which can be simplified to this. A sub 1 over 1 minus r. Right, this is for an infinite geometric series. So a sub 1, again, plug in your starting index. You start at 0. Your starting index is 0 on number 41. So I'm going to plug in 0 here. A sub 1 should be 24. And then your r value is negative 2/3. So this one's not too bad. We're going to plug in 24 over 1 minus a negative 2/3. Final answer should be 14.4 or 72/5. Let's just double check everything. So 0 to infinity. And then we have this as your formula. So with Desmos, it doesn't actually calculate the infinite, but what we can do is just plug in a really big number to simulate infinity, right? So if I just go like 99999, that's pretty dang close to infinity, right? Or it's such a big number that we'll be able to round it to as if it were infinity. So that confirms it's also 14.4, 72/5. There you have it.